Okay, so y equals e to the x is an exponential growth function. Y equals e to the negative x is an exponential decaying function. Our notes up here say growth and decay notes, but in this first paragraph, I don't see anything about e to the x. Do you? Okay, so why would I even bring that up? Okay, you will have to find out. Okay. So, first of all, you are going to get problems, and this happens a lot in science, okay, where you're going to get a rate of change that is directly proportional to the quantity itself. When I say rate of change here in calculus class, what do we think of? A derivative, okay? So, the rate of change derivative is directly proportional not sure why that'll okay, our derivative is directly proportional to the quantity itself. So dy dt, that's our derivative. Y is the quantity, right? When we think of like a function y in terms of x, or in this case y in terms of t, y is the amount over time that it's either growing or decaying. Okay? Now, what we can do is if we know that this is going to come up often, the rate of change is proportional to the amount, we can go ahead and solve this differential equation once and remember what happens. Okay? So let's go ahead and solve this differential equation so we know what it means when the rate of change is directly proportional to the quantity. Okay? So we have dy over dt equals ky. What do we need to do with that? Flashback to yesterday. What do we need to do? Isaac, what did we do yesterday? What did we learn?
You put all the y's on the same side.
Okay, we want all the y's on the same side. And in this case, what's our other variable? T. Okay, k is going to be a constant, different than the plus c. Okay, do you guys remember direct proportional problems? Directly proportional problems you did way back in like algebra, maybe even pre-algebra, and then again in algebra 2. And it basically followed, if y is proportional, directly proportional to x, then we did this. Okay. So in this case, since this is dy over dt, t is our second variable. All right. So we are going to move the dt over to the other side, but then we want the y over with the dy. Do you agree?
Agreed.
I really can't write small, but you probably want to write smaller than what I am up here. Okay, now that our variables are separated, we are going to integrate both sides. Okay. So Madison, what is the antiderivative of 1 over y? What did you say? Y to the negative 2 would be its derivative. What is its antiderivative? Yes, yes it is. Okay? The antiderivative of k with respect to t. Grant, what would we write there?
Be like, well, k is a constant, right?
Uh-huh.
So it would just be t.
Almost.
Okay.
What would that be, Grant?
2x.
Okay. So what would this be?
kt.
There it is. The antiderivative of a constant with respect to t would just be that constant times t, right? Okay, now we have to solve for y, and what did we do in this case to solve for y? What'd you?
E to the power of that.
E to the power of the left side, e to the power of the right side. Okay? E to the natural log will cancel out. We know e to a power is always going to be positive, so we can drop that absolute value sign. Okay? And then we have e to the kt times e to the c if we want to go ahead and break that up. And so then the general solution to our differential equation is y equals c e to the kt. Here is where our exponential growth and decay comes into play. This is an exponential growth problem if what is positive? K. This is an exponential decay problem if k is negative. Change my answer or question. Now, some of you are saying, hey, it looks like PERT.
Correct.
It is PERT.
No, it's correct.
Okay? It's PERT.
It's correct.
It's correct.
What does that say right there? It's correct.
Okay. Now, we are going to call it y equals c e to the kt. If you would like to think of it as PERT, where p is like that principal amount and r is the rate, okay? That c and k act like that p and r in PERT, okay? But what I want you to learn from this,
You have to erase it.
yeah. Okay, what I want you to learn from this is that anytime you have a rate of change that is directly proportional to the quantity itself, we don't have to solve this differential equation every time. We can remember that if this is happening, then y equals c e to the kt. All right, so we have 3 examples, and they're on your paper, so you don't have to write anything down except the work. Isn't that awesome? Okay. Glad I can see some enthusiasm today. All right, so example 1. The rate of change of y is proportional to y. That is just another way of saying that dy dt equals ky. All right? When t is 0, y is 2. When t is 2, y is 4. What's the value of t equals 3? So, first of all, the rate of change of y is proportional to y. That means dy dt equals some constant times y. And we know every time we solve this differential equation, we are getting y equals some constant e to the kt. In order to answer the question, what is the value of t equals 3, what do we need to find out? about our equation? We need to know C, and we need to know K. All right? So, where would you like to start? Anytime they give you t equals 0, it's a beautiful thing. Okay? Because what is e to the 0?
One more.
E to the 0 is 1. Okay? So, if we say y is 2 when t is 0, you just told me e to the 0 is what? 1. So c is 2. Thinking back to your PERT days, what is that c standing for? Thinking back to your PERT days, what is c standing for?
The amount you start with.
The amount you start with, okay? When you plug in 0, e to the 0 goes to 1 and you're left with c. So that c is the initial amount, if you will. Okay? So now we have y equals 2e to the kt. So now we can use the information when t is 2, y is 4. Okay, so divide the 2 over. 2 equals e to the 2k. Now let's just talk about solving this without our calculator. How do I get k by itself without using our calculator?
Natural log.
Okay, we need to write that the natural log of 2 equals 2k. So k is the natural log of 2 over 2. Now, if you're going to go ahead and approximate this as a decimal, you better round to twice as many decimal places as your final answer, okay? So if you're going to give me a final answer with 3 decimal places, then this should be at least to 6 decimal places, okay? My suggestion would be to just save it in your calculator. Okay, so the natural log of 2 divided by 2, 6. 4, 3, 6, so k equals 0.3, 4, 6, 5, 7, 4. My advice to you would just be to keep it in your calculator. A lot of you have TI-84s where it's really easy to go back and get an answer and use it again. Or remember, I taught you, well, you had me last year, I taught you the store feature in your calculator. If you say store, this button right here, store, and then you press alpha in a letter, then it'll store it in alpha A, and anytime you call up alpha A, it'll give you that number. Okay, how many of you remember that from last year? Excellent. Okay, so now what we can say is that our equation y equals c e to the kt. You can either write natural log of 2 over 2t, or you can write 2e to the 0.34657 which is probably what most of you are going to do. Okay. So now we need to know the value of t equals 3. Okay. So what I would probably do, like if I had just put in the natural log of 2 divided by 2, I would probably say 2 times E raised to my answer from before times 3. $5.657. Okay. Did we do any calculus in that problem? Example 1, did we do any calculus? Not really, did we? We did calculus to set up our problem, but that's the only calculus that we're doing today. Okay? All right, example 2. Read through it while I erase. Okay. We know that this stuff is decaying, correct?
Yes.
Okay. What information do we know?
Weight. Mass.
Okay.
What we start with.
Let's go
C.
like that.
C.
What do we start with?
C. 10.
We start with 10 grams of this element, this particle element. What do we call it?
239.
Huh? Plutonium. Thank you. We start with 10 grams of plutonium. That is our initial amount. So you can go through the math. When time is 0, we have 10 grams. Or we can just recognize that since it is the initial amount, we know that that is what C is going to be. C is 10. Okay. Now, we want to know how long it will take to decay to 1 gram, but what must we know first before we can find that? We must know K. Well, we know the half-life is this many years. No. But half-life, if we start out with 10, half-life means it takes 24,360 years to get to how much? 5. Okay. So we can plug 5 in for Y when time is 24,360 years. Can you hear me?
Yes.
Okay. Now, I want you to watch this. What is going to happen if we set up a half-life when we multiply the amount divided by, don't multiply, when we take the amount divided by the initial amount? What's going to happen? 5 divided by 10 is 1/2. Would we need to know anything about the initial amount if we are given information about half-life? Would we need to know the initial amount if we are given information about half-life? Not necessarily, because if this is the amount of time for the half-life, then we know that this right here, when we take Y divided by C, it's going to be 1/2. right? It doesn't matter what the amount is, okay? All right, so then to solve this, we have the natural log of 1/2 equals K times 24,360.
Supposed to be negative?
What do we get?
Negative numbers.
Okay. Not helpful.
Let's say the whole thing is big. Well, it's not big, it's little, but.
Oh my.
Yeah, nope, that's not what I thought.
You get negative 2.845 times 10 to the negative fifth. Here. Okay. Cole, what does your calculator say?
Negative 0.0000285.
Okay. I know that's a little bit more than 6 decimal places. Okay, but since we have all these zeros, okay, we're talking about like significant figures, right? We need a few significant figures.
3.
3 would be great. All right. So now we want to know, okay, we have K and we have C. How long will it take to decay to 1 gram? Where are we putting 1 in for?
C1,
Y. We already know C, we already know K. Those are constants, they stay. All right? T is time, Y is an amount. And so since they gave us 1 gram, that's an amount, it goes in for Y. Okay, so we can divide by 10. Then what do we have to do? I would not
Well, no,
divide.
natural law.
Thank you. So we have the natural log of 1/10 equals negative 0.0002. Whoops, grab 0. Okay, so if this were me, I would just take the natural log of 1/10 and then divide by my answer that I already have in my calculator so I don't have to type it out again. $80,922.168 years. So just over 80,922 years.
I got 80,934.
792.
Yeah, 80,000.
I'm getting different answers. Like I got 792.
Do you have the natural log of 1/10
Yes.
divided by the answer from your calculator?
Yes. Negative. I'll even put exact answer.
Oh, okay.
How many zeros are there? 4? 2, 8. Oh, now I got 934. You have 934.
So you got that because you just typed that in.
Yeah.
Okay.
I got that as well.
Okay.
I got your answer.
And because you use the exact thing from your calculator. Okay. The smaller the number, the more you're going to be off if you cut off the rounding. And so if you like typed this in, you're gonna be a little bit off of my answer. Does that make sense? Okay. This is a pretty large time, like for a half-life. They're not going to be this extreme. But I would say the more that you can keep in your calculator, the better off you're going to be. Okay. Use your calculator, it's fancy. All right.
Elements don't have lives.
Last question, read through it, please. Read through number 3. Okay. First sentence, the rate at which acreage is being consumed is proportional to the number of acres already consumed. All that is saying is that the rate of the amount is proportional to the amount itself. And we know if that is true, then our differential equation is y equals c e to the kt.
Can you say it just once? You gotta just say it.
Kazoo?
What? Where do you get kazoo from? Oh, no, not kazoo. Cat. Who's called cat?
Y equals c e to the kt.
Just what?
All right. If there are 2 acres consumed when time is 1 and 3 acres consumed when time is 5, how many acres will be consumed when t equals 8? All right. Did they give us the initial amounts? Darn it. Okay. So, this is what we have to do. When t is 1, y is 3. So when t is 1, y is 3. And when t is... Oh, y is 2. Thank you. When t is 1, y is 2. When t is 5, y is 3. We have 2 equations and 2 unknowns. That's perfect. We can solve for both. But how will we solve for both?
You have to just you can just sort of cancel them out from both sides somehow, and then you can just.
So there's a CE plus the CE.
What do you mean cancel them out for both sides?
Sort of. I mean, you have to manipulate the numbers a bit, but it's possible to just track in a certain way.
Oh yeah, isolate a variable and substitute.
Okay. We kind of have 2 different ways, because Austin, you are right, there's a way to kind of
Think straight.
subtract them or divide them to get what we want. There's also our handy-dandy method of substitution. How long have you guys been working with substitution for 2 equations, 2 unknowns?
Each class at least.
Okay. So you can do this a number of different ways. Okay. But probably the most straightforward would be to use substitution. That's probably what's going to come back easier for your algebra skills. All right. So this is what we can do. What would be easy to solve for in this equation?
C.
C. C equals 2 over e to the k. Right?
Yes.
Then we can come over here and we can plug that in. C is 2 over e to the k. Okay, we have e to the 5k divided by e to the k. So that is e to the 4k. Do you remember our rule? If we are dividing same base, we can subtract our exponents. So since we have e to the 5k divided by e to the k, we're left with e to the 4k. All right, and so from here it becomes simple. Okay, we have 3 halves equals e to the 4k. So then the natural log of 3 halves equals 4k. Okay, so k is the natural log of 3 halves over 4. If you want to approximate that, the natural log of 3 halves divided by 4. And so that is 0.101366. If I were you, I would store this in alpha k, k4, we solve for k, and then you can just call it back up. Or if you have an 84, you know you can arrow and highlight answers to bring them back up, right? Now, we need to figure out what C is. Now that we know what K is, okay? And so C is just 2 divided by E raised to the K. All right, since I stored that in K, I'm just going to bring up K. Otherwise, you can go and highlight that number, or you can type in the natural log of 3 halves divided by 4, whatever you want to do. Okay, and then for me, I'm going to store this in alpha C, because that's what I solved for is C. Okay. So now we have K and we have C. So Y equals C e to the KT. We need to know how many acres will be consumed when T is 8. So we're going to plug in H for T. So we have C times E to the K times 8. What's our answer? 4.066. You didn't do your stored numbers and what ended up happening with your numbers?
It was a little worth it.
Okay, so you were able, yours was like 4.067,
Yeah, it's like 0.0.
and so you were like, okay, that, all right. I would suggest using the stored feature in your calculator because you have it, and it's going to give you exact answers, okay? All right, what questions do you have?
Did you get it? C is 4.0. Whoa,